Okay, welcome back. What we're doing is we're going to be talking about rational functions in this chapter. Now, this chapter, the rational functions chapter, is an R. And we're starting with section R4. We're going to be starting with a factoring review. We're going to be going over all different types of factoring here. Now, we're going to be going over the odd problems. The even problems will be on your own. So now, for problem number 1. When we see four terms, actually, you know what? Before we do this, let's review a couple key factoring things. A squared minus b squared. The difference of 2 squared, that's always going to be a plus b, a minus b. You want to put this down for reference. A squared plus 2ab plus b squared. That's going to be in the form of a plus b squared. A squared minus 2ab plus b squared is in the form of a minus b squared. A cubed plus b cubed. We talked about this in the last section. That's going to be a plus b. A squared minus ab plus b squared. And then a cubed minus b cubed. So that's going to be in the form of a minus b, a squared plus ab plus b squared. And when these come up, I'll refer back to these patterns. Now, for number 1, it doesn't fit any of those patterns. This is an example of factor by grouping. Group the first two terms. The common factor is x squared. So we factor out the x squared, we get x plus 4. The last two terms, the third term is negative. We're going to take out a negative. And the common factor is a negative 9. Divide those by negative 9, you get x plus 4. Now, what's common between that big term and that big term is the x plus 4. We'll put that out front. And when we take away the x plus 4, we're left with x squared minus 9. This can be factored. It's a perfect square minus a perfect square. It's our first special factoring pattern. So it's x plus 4. And now, in our binomials, the square root of x squared is x. That goes in the first spot. The square root of 9 is 3. And then we just put a plus and a minus. That polynomial was factored. X to the 4th minus 16. That's a polynomial in quadratic form. It's actually our top example, the x squared minus a squared minus b squared. So for our binomials, the square root of x to the 4th is x squared. The square root of 16 is 4. And then we just put a plus and a minus. We can't factor x squared plus 4, but we can factor x squared minus 4. It's that a squared minus b squared again. So it's going to be x squared plus 4 still there. The square root of x squared is x. Square root of 4 is 2. And then we just put our plus and our minus. Now that is completely factored. This is really all about practice right now. For number 15, looking at those two terms, there's a common factor of 15. X squared is the greatest common factor. So when I divide those terms by 15x squared, I get x minus 3. And that's all we can do to factor that polynomial. Number 7 is a more traditional, like we're used to. X and x. Now, because it's just an x squared, we want to think about what numbers multiply to negative 10 and add to negative 9. To multiply to negative 10 and add to negative 9, we'd need a negative 10 and a positive 1. So it'd be x minus 10, x plus 1. Can't factor any further. There we go. For a problem like number 9. So this one, because of the 8x squared, a little bit more complicated. So what we have here, we multiply the first and last term. So we get 8x squared goes on top, negative 6x goes on the bottom. Now the numbers that multiply to 8 and add to negative 6. Now since they're multiplying to a positive, they have to have the same sign. So negative 4x and negative 2x will multiply to positive 8x squared and add to negative 6x. Here we can use our grouping method, 8x squared and the 1 That's our original first and last terms. And now negative 4x and negative 2x go in the middle. First two terms, the common factor is 4x. And then we're left with x minus 1. Last two terms, the common factor, third term's negative, so we'll just take out a negative 1, and then we're left with x minus 1. So our factors, x minus 1, and then 4x minus 1. And we just factored that quadratic. Problem number 11. Only thing we can do is take out a common factor. In this case, it's just an x. And we're left with 7x minus 3. That's all we can do. That is fully factored. On the next page, we see another one with 4 terms. Think factor by grouping. Think about that grouping method. So the common factor of those of the first two terms is 25x squared. So we take that out, we're left with x minus 1. Third term's negative, we'll take out a negative, and the only common factor is a 1. And then we do that, we get x minus 1. Our common factor between the both is x minus 1. When we take that away, we're left with 25x squared minus 1. Now, 25x squared and 1 are perfect squares. It's that a squared minus b squared again. It's a plus b, a minus b. So it's x minus 1 is still there. The square root of 25x squared is 5x. The square root of 1 is 1. So we just put a plus and a minus, and now we are fully factored. 2x cubed plus 54. Now, all we can do is take out a 2. Always look for that common factor. Then we're left with x cubed plus 27. X cubed is a perfect square, or a perfect cube, and so is 27. This is in the form now of a cubed plus b cubed. So when we factor it, we get a plus b, a squared minus ab plus b squared. Now, a is the cube root of x cubed, and the cube root of x cubed is x. B is the cube root of 27, and the cube root of 27 is 3. So it's 2. And now we just fill in our values. A plus b, so it's x plus 3. A squared, so it's x squared. Minus a times b, so minus 3x plus b squared, and 3 squared is 9. That polynomial is completely factored. Looking at problem number 17 now. We can factor out of 5. 5, and then we're left with x squared minus 5x plus 6. Now it's a more straightforward factoring problem. We put our x and x to begin with. Now we want to think what numbers multiply to 6 and add to negative 5. Only way they can multiply to a positive and add to a negative is if they're both negatives. Negative 2 and negative 3. They multiply to 6 and add to negative 5. We just factored that quadratic. Number 19, common factor. We can take out a 2. So we're left with 2 times 9x squared minus 1. Once again, 9x squared is a perfect square. So it's going to be a plus b, a minus b. So it's 2 times. Now, the square root of 9x squared is 3x. The square root of 1 is 1. And then we just put our plus and our minus. And we are factored. There we go. That's why that special case is so important to know. It just makes things so much easier. Number 21, no common factors here. Multiply the first and last. We got a big number. So we multiply 15x squared times negative 16 is a negative 240x squared. At the bottom, we have our positive 8x. Now, there's a lot of different combinations here. Luckily, 240, that's divided by 20. And 20 times 12 would be 240. and that's 8 apart. So it's going to be a positive 20x and a negative 12x. That's going to add to a positive 8. So if we look at our grouping method, first term, the initial, 15x squared. Last term is still negative 16, so we have our plus 20x minus 12x. Common factor of the first two terms is 5x, so we're left with 3x plus 4. Last two terms, our common factor is a negative 4, and we're left with 3x plus 4. So our common factor is 3x plus 4, and then we're left with 5x minus 4. So there's our factors, 3x plus 4, 5x minus 4. And now the last one. Just an x squared out front, a little bit easier. So we have our x and our x. Now we want to think, what numbers multiply to 15 and add to negative 8? Last number is positive, so they have to have the same sign. Bottom number is a negative, so they have to both be negative. So negative 8 would be a negative 3 and a negative 5. So it's x minus 3, x minus 5, and we are factored. All right, that's some factoring review. I'd like you to do the evens, please. As your assignment for extra practice, we're going to be using factoring throughout the rest of the chapter. It's important you know how to factor from this point on. Thank you, and I'll see you in the next video.